Everyone, thank you for joining us. It's so exciting. I'm Ian Shapiro with Syracuse University. We are going to do something super exciting today. We're going to do not only a hybrid presentation, in other words, with people here and people remotely, we're going to be delivering it with one presenter here and one presenter remotely, both from Lawrence Berkeley National Labs, Tianzhen Hong here today, and remotely his colleague Reshma Singh. So this is part of our Department of Energy EPIC program. EPIC is the Energy Program for Innovation Cluster. So it's a program for startup companies, supporting startup companies in the green energy field. It's our third year in the program. And today, the overarching goal and the takeaway that I'd like you all to think about is the fact that our national labs are national treasures. I've been working as a practicing engineer for 40 years and have worked with virtually every national lab, Brookhaven National Lab, Oak Ridge, National Renewable Energy Lab, Pacific Northwest National Labs, and Lawrence Berkeley National Labs. When I tell you that they are national treasures, I mean it. In my course on measurements that I just taught, I'm asking the students to go to the LBNL website to do thermal comfort calculations. The resources out of the national labs are endless. So the message to startup companies, we've got great partners in the national labs. Today, Tianzhen Hong, Dr. Tianzhen Hong, Senior Scientist and Interim Deputy Director for Research of the Building Technology and Urban Systems Division of LBNL, Lawrence Berkeley National Lab. Highly cited researcher and fellow of IBPSA, and if I'm not mistaken, International Building Performance Simulation, the A Association, almost. And ASHRAE. His research focuses on new methods, models, data, tools, and simulations to evaluate technologies and human behaviors, supporting building decarbonization and climate resilience. Remotely from LBNL, Reshma Singh is a program director at LBNL, where she leads the technology to market IMPEL and Cradle to Commerce incubation engine. She also leads the Net Zero World Initiative's Climate Smart Women's Energy Leadership Program. Reshma is also senior advisor at US DOE's Building Technologies Office. And in fact, Tammy tells me that Reshma has been involved in EPIC in recent years. I only joined EPIC this year, where she guides technology to market pathways for decarbonization solutions, promoting equitable wellness and resilience for all. Exactly what we're trying to do with our EPIC program. And so today, Tianzhen and Reshma presenting on buildings and communities pathway to carbon neutrality and climate resilience. Please join me in welcoming Tianzhen. This mic, and then
this is for Q&A. Okay, good, yeah. Good morning, everyone. Yeah, I think some of you were here probably Monday and yesterday. Professor Lee here gave a very inspiring talk about, some of the amazing technology in the future that can address some of our, challenges of, energy use and carbon, climate resilience issues. So yeah, as you mentioned, right, very happy to be here today to introduce some of the lab capabilities and also opportunity for collaboration. I think a lot of things we develop, right, we are spending taxpayers' money. So I think it's a very good connection for the startup companies and university to think about collaboration, how to use the lab capabilities, but also facilities for testing, prototyping, some of those designs and technologies. So I will introduce some more on the research side, and my colleague Reshma will talk about some of our activities, tech to market, and some of the programs supporting, startup companies. Let's see, so maybe I can use this one. Let's see. So okay, good. Thanks. Yeah. So now it works. Yeah. So just a few very high levels about the Berkeley Lab, and I think some of you may already know, but some of you may not. So it's a lab as part of the Department of Energy's national lab system. So DOE has 17 labs. So LBNS is one of them, but a lot of the things we do at Berkeley Lab is fundamental science. So we are the only area doing energy technology. But here just shows you some of the higher level numbers about our lab. So as you see, right, because we're doing fundamental science, we have 16 Nobel Prize. Those are the winners in physics, chemistry, biology, computing, studying dark matters and universe. And but as you see, we have a lot of technology innovation. They won the national medals, and I would give some examples. So we have about 3,600 full-time employees, but there's a lot of postdoc students and visitors from all over the world. So the lab is structured like with 6 science areas, and as you can see, so we have like bioscience, we have the computing science, earth and environmental science, energy science, doing more fundamentals about energy generation, materials. So we are at the energy technologies area, and Marianne Pierre is our associate lab director. So underneath we have 3 divisions. So I'm with the Building Technology and Urban Systems, and Jessica Granderson is our division director. But we have 2 other divisions that doing some policy analysis, appliance standards, but also energy storage and power grid, those kind of technologies. And of course we have the physical sciences, which has been historical by doing very impressive research. So for the energy technologies area, so we have about 450 people, working under the 3 divisions. And broadly, these are the 3 categories of research we have been doing. I think the first one is a demand side system. So this covers buildings, industry, and transportation. So basically, we try to understand what is the opportunity of energy efficiency. How can we reduce the energy loads, the energy demand? And of course, now we are also interested how to make sure that our energy demand is so flexible, because our energy supply from the power grid is changing, right? During the middle of the day, you have more clean energy generated from PV systems. So we're also interested in the energy supply and storage, because the nature of the dynamic of the energy generation, the energy storage is a key technology when we think about how we decarbonize the buildings, sector. There's research also in clean fuels, hydrogen, different kind of storage, technologies. So the first area is about analysis and environmental systems. So this is more doing a lot of modeling analysis to support policy making, support technology evaluation, tech economic analysis, life cycle cost analysis. Especially now, there's also interest in the embodied carbon, as we are pushing the operational carbon to like net zero, but the embodied carbon becomes a growing percentage of the life cycle carbon emission from our buildings and facilities. So how we use those kind of life cycle analysis method is also a emerging research area. And we are interested in co-benefits of building decarbonization. It's not just reduce energy use or carbon emission, there's also health of the occupant from the indoor air quality perspective. I think for the last 2 days, we have lots of talks, mentioned And sometimes those are benefit can be more than the energy benefit. So I think we just need to consider all those together. And also with the extreme climate, weather conditions, and sometimes we have power outages, we have hurricanes, we have extreme heat events. So how to ensure our facility, our infrastructure is resilient, as well as buildings can still operate during those extreme conditions. So, occupants can still, be safe, indoors. I think those are also very important aspects to consider when we try to design and operate our building. Supply chain, I think this is also a new area. Department of Energy is, supporting a couple programs, try to look at, the supply chain, securities of those, supply of materials and equipment. So just the lab was funded by Orlando Lawrence in 1931, and he's a physicist in nuclear physics, and he won a Nobel Prize in 1939. But R. Rosenfeld is the original funder of our energy technologies area. So that was in the early 1970s when the first oil crisis, embargo. So he was actually a physicist, a student of Fermi, but then he got assigned to think about, well, how can we reduce the demand, right, from our buildings? And so he funded our, it's called Building Science Research Center at the time. Just started with a few people, and now we evolved into a 450, research area. And he won this National Medal of Technology, and there's a picture here, right, with former President Obama at the White House. That was in 2013. So yeah, he passed away in 2017, but his legacy is right. He's still there. We are carrying his torch, going on, and I think it's an exciting time. So, so a few icons there just illustrate some of the technologies Berkeley Lab have been working since 1975, and so I think that we have been working on the window technology, how to ensure our window. That particular one is a double pane low E windows. And so, right, 50 years ago, you would think that's crazy, it's very cost, very expensive. But now it's basically the very minimal requirement in our building energy code. So technology, right, take a long time from your original development, testing, improving the cost effectiveness, all the way to, broad or massive, deployment. We have folks working on these standby laws, and so basically help California and Department of Energy to develop those testing procedures and support the development of the standards that regulate the standby power. We have billions of electronic devices. Each one uses a very small power, but imagine so many of them, and even if you plug it in, you don't use it, they're still consuming energy. So how we develop standards to regulate that. So that's appliance standards group. And we also been developing tools like Energy Plus. So it's used to model performance of buildings to help us inform better design operation. We have worked on cool surfaces, cool materials. And OpenADI is also a communication protocol that utility want to send demand response signal. So you have to use certain communication protocol. So mainland Pierre is LD has been working on in this area. So this is also important research topic at our lab. So at building technology and urban systems division, so our work covers like a different type of buildings, commercial, residential, industrial, and data centers. I think I mentioned yesterday, it's a growing sector. It's more AI use, like GPU chips and all those kind of things. So we're also thinking about how to improve energy efficiency of data centers. And we work a lot. It's basically try to develop new technologies and develop standards that inform the industry and different sectors, and also develop some best practices to inform technology adoption. And we have facilities that basically can help you design and test the performance of your technology to help reduce the risk, because industry sometimes it's not it's maybe conservative in terms of technology adoption, but if we can demonstrate that it work at a lab or work in some pilot projects in real buildings that would help them gain confidence. So I think that's also an opportunity. We've been working with, industry. So I think I mentioned some of the window technologies, but basically, right, from the double pane OE, we're interested in dynamic windows because our building loads can be different time of the day, different day of the season. So sometimes we want, right, the heat transport is this direction, sometimes we want the other direction. So how can we make sure our window has dynamic performance? So that's also, a research area we've been working on for a long while. And I mentioned the co-benefits of health as we try to decarbonize our buildings. Can we ensure that our buildings are also healthy and also, climate resilient? We also work on grid integration. So this is grid interactive efficient buildings. So we led the development of this roadmap for Department of Energy. But basically think about, right, building, you may have on-site energy generation from PV, you may have battery, you may have EV charging, all those loads, how you integrate them together. Also consider the supply signals from a power grid. So there's this is emerging opportunities. And of course, I think earlier mentioned the storage, right? It's a key piece of this, try to balance the supply and the demand, right, during different times of the year. We have a research area led by our division director, Jessica Granderson, basically to looking at what are the opportunities of AI, machine learning, or traditional data analytics to understand how our building operates, how buildings or our occupants are consuming energy. This is how much is for lighting, how much is for HVAC systems, how much is all of those stuff. So by looking at more and more available large volume of building data, we do the data analytics, try to understand are there operation problems with our device, with our equipment, with our systems, right? And then estimate if we correct those problems, those operation faults, how much energy saving, utility cost saving can we achieve? So that is a very practical research area that Jessica is leading, and I think there's companies interested in working with us, basically testing their different kind of algorithms. They want to see, right, is these algorithms performing better than the others, and so that's a research area. We developed tools. I think later I have some examples. Okay. I mentioned, right, we work with different type of buildings, and within a building, we work from component to system, and whole building, whole home, and also to communities. So I think what's illustrated here are a few programs funded by Department of Energy. One is efficient and healthy schools. I think yesterday workshop I talked about our schools, and so the federal government, also the California's state agency, also funded a program basically trying to improve the energy efficiency, but more important is the indoor air quality of schools. So some of the schools, right, traditionally don't have air conditioning during summer, but we experience more hot summer days. So some of the classrooms through measurement, we found the temperature up to 30 degrees Celsius, right, and the CO2 can be up to 2,000 or even 3,000 ppm. And I think under those kind of indoor environments, students would not be able to learn effectively, right? So there's funding goes to support schools, to retrofit facilities, to air conditioning, but better insulation, ventilation. Those are very important programs. There's a connected communities. So these are, we think about building decarbonization, right? If we do one building at a time, it's going probably to take us a very long time to achieve our goal. Right, and so how about we do a community together, right? And there will be new technologies that becomes more effective if we look at a community scale, district energy system, community PVs, and I think yesterday there was also some discussion, right, talking about this. That's urban heat island. That's a research area we do. Let me mention. Okay. So a lot of the building code standards, right, focus on new buildings. But thinking about the US, right, majority, I think it's the existing building stock. So the challenge is how can we retrofit those existing building stock, right, to reduce energy use, to decarbonize them. So DOE has a program called Building Performance Standards. Basically, it helps set local governments to set targets to do the energy efficiency improvement to reduce the energy use and carbon emissions. So there's more and more states and cities and sign up for technical assistance under the building performance standards program. So we developed tools, and I think this is one example of the tools that be able to model every building in the city. And then you can do asking questions like for this group of building, if I want to reduce its energy consumption or carbon emission by 50%, what can I do? What kind of technology I can look at? So we have a library of different kind of technologies that you can apply and then do the simulation. It gives you estimates. Those are kind of benefits. So these kind of tools allow the public, whatever users that, to look at those kind of, scenarios, quickly. It's a starting point to inform their, decision making. If you're interested in more advanced energy and control systems, and there's another tool chain based on Modelica, it's called Spawn. And so I think it's quite modular, I think similar to what Jason, your team has been doing, how to put together all these different kind of modules together to create a capability to evaluate your systems and control strategies. And this is open source. I think the previous one is not open source, but it's free, it's open access. So we have user facilities, and just a few examples here. Flex Lab is a advanced facility, allows users design your experiment, and so it shows each test bed has 2 identical cells, so it's very easy for you to do the comparative testing. And there's also one rotatable, because sometimes you're testing facade technology, right? Or orientation, the solar angles, those are sensitive. So there's also one that can rotate, and it is very highly instrumented. Each test cell, we have hundreds of sensors. Every socket is a separate meter at a 1 or 5 seconds interval. So you can do very precise design testing, and it gives you all the data for you to do the analysis of how a particular technology or control works. We have test chambers, psychrometric chambers, and earlier mentioned some of the home appliances, testing chambers. We have a very high precision facility to measure the thermal and optical properties of glazings and windows. There's also indoor air quality measurement facility, and this is shows some of the, when we electrify our cooking, there will be reductions of those pollutants. So we try to quantify, what is the benefit of the, indoor air quality improvement. So I try to give you a few examples of what we do. I think we talk about decarbonization, efficiency, flexibility, and climate resilience. So this is an example. We study these 1,000 single family and multi-family buildings in Fresno, California. So it's in the Central Valley of California, and it's an agriculture-driven economy. So it's low-income communities. It also has, outdoor air pollution. So then the question the state is interested asking is, for these kind of communities, how can we help them, right? How to decarbonize, their building stock? What is the pathway for them to get to clean energy? So we create models for these 1,000 buildings, and then we take a look at like 17 different kinds of technologies, and we then create a package with these 8 listed technologies. And basically, based on our modeling and simulation, we show by applying these package of technology to this 1,000 building, we're able to achieve 63% reduction annual energy and carbon reduction. So that's your, and if you look at the list, right, these are technology already available today. LED lighting, add more insulation, window frame, you can buy it from Home Depot, do it on yourself. Basically, it's try to reduce the solar heat gains through windows during summer. Right, it's a heat pump for space heating and cooling, heat pump water heaters, so those are all today's, technology. So if we apply as a package, we're able to, achieve, more than 60% of reductions in carbon emission. There's a different kinds of technologies for energy flexibility, and so the figure shows this is the electricity's, carbon intensity in California. So basically, the blue ones shows these are the more clean energy because more production of PV during the middle of the day, during the early spring and summer. So projection to 2030, then you can see there's more green, clean energy during the day and also during the the summertime. So how can we design, operate our building and systems to use more energy during this time of the year, right? And try to use less during when electricity expensive or when it's dirtier. So there's a efficiency technology try to reduce the demand permanently, consistently. The load shedding, if I dim the lights during when the electricity demand is high, right? Or we sort of relax our cooling set point instead of 24 degrees Celsius, maybe we raise it up to 26 degrees Celsius for a few hours. Then it can help us reduce a lot of the peak demand for cooling for other services. Energy storage can help us move, right? The peak demand energy need. We charge our storage systems during the night, use it during the early afternoons. So the different kind of technologies that can help us achieve the energy flexibility. So in California, basically our peak electricity demand is switched to early evening or early afternoon from 4 p.m. to 9 p.m. And that's also the residential customers have to pay a much higher price if you use electricity during these 5 hours and window. So that is a motivation for the residential customers to think about, right? You want to do the laundry, not in this period, right? You want to charge your EV maybe during the middle of the day or some other times, to save the utility cost. So another example is to look at the climate resilience. So use the same tool I mentioned, particularly this example is to think about very hot summer day, like a heat wave. We look at this historical heat wave 2006. In Fresno, it's 5 days in a row that the daily maximum temperature is higher than 111 degrees Fahrenheit. So think about this time, sometimes the worst case would also trigger the power outage. So we're interested in looking at the scenario. If there's a power outage right during these 5 days, what will be the indoor temperature? Will it cause extreme heat risk, to the residents? So we look at some of the passive technologies, and passive means these are the technology does not need energy to operate. And as you can see, a lot of technologies about reduce the solar heat gain through window, right? Solar shading, better performance of window, solar flame earlier mentioned, try to reduce the heat, right? Transfer through the roof. Also, we look at the natural ventilation. It can be a very effective measure to help mitigate the heat risk during this kind of extreme situation. Because what happens is your building can trap heat indoors and causing your indoor temperature actually higher than outdoor. So it's obvious, right? You want to open windows, right? To try to, relieve the heat. So this is also something very easy to do. And so we do some simulation, be able to show by applying all these passive, measures together, we can almost eliminate the dangerous conditions using the heat index as a matrix. But that is the dangerous condition. If you still want to maintain the comfort condition, then these passive measures definitely are not enough. You will still need air conditioning. So that's right. With technologies we develop, including this is example, is a model predictive control. So a lot of the buildings operating today are based on rule-based control. Means at a certain time, I turn the system on. At a certain time, I turn the system off. Right, or I, adjust my thermostat set point. But think about our buildings are dynamic. Our weather conditions are changing, right? Occupancy is changing, loads are changing, the electricity price from power grid is changing. So how can we optimize our building operation, right, to achieve the, minimize your utility costs or minimize carbon emission? So basically, we developed this MPC, it takes the prediction signal, the signal from power grid, and through optimization, we're able to optimize our building operation. And we demonstrate this in real buildings, the office building in our campus. It shows the 44% reduction in HVAC energy use. We apply the technology to a UC Marseille, so it's a campus. There's a huge energy storage tank there. They have PV. So by applying MPC, we have the campus achieve a 15% reduction in peak demand. So that translates to more than $12,000 per month of utility cost savings. I mentioned connected community. So these are a program funded by the Department of Energy. It's a 10 projects, total of 61 million. And I think there's a call for proposal for these connected communities 2.0. And so basically, this is a program designed to help communities address their needs of, either decarbonization, electrification, energy retrofit, EV charging, or some other kind of climate resilience, issue. So they have, looking at the combination of different portfolio of technologies and how to think about cost effective if they implement, at a community scale. So there's a project across different, states and different locations. So this is the last slide. And if we think about the technology applied to our building industry, I think MIT Technology Review is good always highlight the 10 breakthrough and popular technologies. And I'm interested because when I look at this figure, right, I see, oh, wow, the 6 technologies are directly applied to our field. Think about AI for everything, right? We are not just one thing. It's a very important thing, right? The building sector. The PV stuff, we still want to improve the efficiency. I think currently maybe 22%, but right, there's still far enough potential there. There's a geothermal. This is for power generation, but we also use for heating, for cooling. There's a heat pump, right? Technologies. There's a exascale computing. And as I mentioned, if we want to model the entire region, coupling, building, transportation, land use, and power grid, we will need this kind of computing capability. And Apple's, this is the VR technology, right? Robotic, and I think this is a particularly very important thinking about the construction technology for our future, the 3D printing, all those kind of things together. So yeah, with these 6 exciting technology, I think the opportunity to think about how we apply them to our buildings industry to help us achieve our goal. So with that, I want to pass to my colleague Reshma to talk about some of the tech to market and some of the programs to support startup companies.
Good morning, everybody. My name is Reshma Singh. I'm joining here from Berkeley, California. Hope everybody is doing well. I hope you can see my screen now. Yeah.
Perfect.
Awesome. Can you hear me okay?
Yes.
Great. Wonderful. So again, as my introduction, I'm the program director at Lawrence Berkeley National Lab for 2 tech-to-market programs called IMPEL and Cradle to Commerce. And as Tianzhen mentioned, that we at LBNL have had a rich history of building technologies starting from the 1970s. And in the past 5 years or so, we've actually launched 2 programs that I've been fortunate to be very involved in under the leadership of Marianne Piet, Jessica Granderson, and Tianzhen Hong, who are our fearless leaders at LBNL. One is called IMPEL, which was launched in 2020, and the other one is Cradle to Commerce, which was launched just last year in 2023. So I'm happy to share more information about both these programs as they may be relevant to academics, researchers, and startups, as well as nonprofit organizations that are working in the clean energy and buildings decarbonization space. So let me start with IMPEL. Our website is impel.lbl.gov if you want more information. So IMPEL really tackles the issue of the built environment. So as you know, the built environment really represents about 40% of global fuel-based emissions. And it's a very, very important sector because across the world, globally, half the buildings still need to be built. And unlike electric vehicles and batteries, which have much shorter lifespan, but are a very strong emphasis of climate tech and clean tech these days, buildings are built to last for 50 to 100 years. So we better build them right in a way that's decarbonized. However, buildings are a tough to invest in sector, particularly because of all the hard moving parts in the building, from equipment such as HVAC, which has a lot of climate implications, to building materials such as insulation, walls, and windows, some of which that Tianzhen talked about in his talk. And we need to have long time horizons to make hard technologies happen. And we really don't have the time in terms of a climate future. So we need to make sure that we accelerate these building technologies using public and private sector funding and investment. So IMPEL was launched 5 years ago. This is our fifth year for IMPEL. IMPEL stands for Incubating Market-Propelled Entrepreneurial Mindset at the Labs and Beyond. And we launched this as an innovation engine for early stage technologies. They can be researchers, scientists, professionals, and entrepreneurs. And the mission is to help you impel your building and energy innovations to climate impact. So this is supported by the Building Technologies Office at the DOE, and Lawrence Berkeley National Lab implements this program for the DOE. So what we have been doing in the past 5 years is we've been looking across the US for folks who are early stage, building decarbonization, folks who really want to move the needle and bring their technologies from early stage to commercial impact. So we've actually seen that 90% of our IMPEL innovators have began the journey as early stage, pre-commercial inventors, researchers, and entrepreneurs. And now post-IMPEL, you'll see that, number one, we straddle across the country. But post-IMPEL, almost 1/3 of our entrepreneurs have moved into technology and market de-risking. So really moving from TRL 1, 2s, and 3s, all the way to TRL 9s and 9+. So commercialization really is our mantra. So what we tackled at IMPEL is barriers faced by early stage innovators. We have done a survey of IMPEL innovators and found that most of the barriers are technical and operational, specifically in terms of high upfront costs for R&D infrastructure, market and policy barriers, which is low public awareness of technology, as well as complexities of existing infrastructure and regulations, and of course, bringing together a financial capital stack, which is lack of access to suitable investors who can have long investment horizons. So what we're doing through IMPEL is trying to target each one of these barriers by producing ways to accelerate technologies and producing pathways that our innovators can take and knock down these barriers. So our theory of change at IMPEL is to accelerate building technologies for climate adaptation. So we want to get to a carbon neutral built environment that promotes equitable wellness for all. And we take each one of these aspects very seriously. Carbon neutral is really around decarbonization. Promotion of equitable wellness is through democratization. And we also use digital technologies to enable getting to these goals. So essentially, all of our technologies are categorized in 3 categories. First of all, technologies that help to decarbonize, which is to radically reduce emissions through embodied carbon, operational carbon, as well as using circular materials and energy flows for a circular economy. The second set of category is digitalization technologies, which is connecting the buildings and the building's edge. The building's edge is essentially the clean energy system, which includes the grid, renewables, EV charging, and energy storage. And finally, the most important one is making sure that these technologies be accessed by everybody equitably. So we provide democratization technologies for wellness, which includes thermal and visual comfort, for health, which includes technologies for air pollution and air quality, disaster resilience, and human capital development. So what we offer really is 3 sets of trainings through IMPEL. It's a year-long program for researchers, academics, and startups to go through. We start with foundational training, which is through pitch workshops, mentoring sessions, as well as sessions on carbon tools to enable our technologists, our innovators to understand the carbon impact of the technologies, as well as providing a peer learning community of innovators. So that's really our foundational training. Then half of our innovators get down selected for advanced business training, which is essentially going into business model development and selection for 3 pipelines. So we have a grants pipeline, a venture capital pipeline, and industry partnership pipeline that we help nominate our innovators for. And then finally, a little bit more color on the pipelines. We have funding and demonstration opportunities. And here you can see a bunch of IMPEL innovators at various events, such as the DOE IMPEL National Showcase, which is held at the DOE Peer Review, the Greentown Labs Incubator Showcase, which is with private sector investors, the HUD's Innovative Housing Showcase in DC, which is actually coming up in June this year again. And then we also nominate for various demonstration pipelines, such as with ESTCP, through the Department of Defense, through GSA's Green Proving Ground, as well as other opportunities through national labs, such as the LEAP programs, as well as Cradle to Commerce program. So we essentially have built an ecosystem of the DOE, HUD, DOD, GSA, and NASIO as a fulcrum of federal government and state government bodies that can help address acceleration of building technologies to market. Apart from our coaching, we also have a very strong stable of experts that provide mentorship to the program innovators. So we have investors and industry partners that bring their expertise on the financial side and industry side. We have policy and demonstration experts, and we have entrepreneurs who've done it before, as well as subject matter experts from various national labs. So together, our mentors are able to guide and help the innovators navigate their pathways. Another point of differentiation in IMPEL is that we provide carbon tool sessions. We've partnered with the Carbon Leadership Forum, as well as national labs who bring DOE carbon footprint calculators such as GREET and SCOUT to our innovators. And we've also partnered with Prime Coalition and their tool Crane, so that all of our innovators can not only pitch their ideas in terms of how to come to market, but also understand what is the projected carbon impact of the technologies. So here's an example of slides on how we are able to help our innovators make assumptions that are vetted, and also provide a carbon slide as part of the pitch deck to VCs and grant-making bodies, which is really helped with the assumptions with the national lab experts. So across our 5 years, we've actually helped support 250 innovators. We have helped them access over 170 awards, grants, prizes, and pilots. 200 new green jobs have been created beyond our innovators who have participated in the program. And even though our innovators have been very early stage, they have managed to raise over $100 million in funding. And some of my favorite metrics is that although a lot of accelerators exist in the US, they are really focused on the two coasts. It's usually New York or California, but we've actually managed to touch over 35 US states and territories, and over half of our innovators are women and people of color. So whereas VC funding, only 2% goes to women and only 1.5% goes to people of color, we have supported and provided a platform for equitable entrepreneurship in the building decarbonization space. So I'll give you a couple of examples where our IMPEL alumni have actually gone on from starting off their journey at very early stage at the benchtop testing stage and have now gone on to create 3 new manufacturing facilities. So Hempitecture is creating carbon negative building insulation using hemp, and they have actually raised over $4.5 million in funding. And these funds are being built to, have been used to build a manufacturing plant in Idaho. And they already got several customers, especially pilot customers, where they're able to bring their high R value insulation into real life buildings. InventWood is another company out of Maryland. They came out of UMD. After they went through IMPEL, they also received the Green Healthy Accelerator prize through our partner Greentown Labs, and also received a $20 million scale-up award from ARPA-E. They are building a facility in Maryland, which is producing their patented metal wood, which is essentially a honeycomb-like structure where wood becomes almost as strong as steel for certain building applications. AeroShield is another company which came out of MIT. After they went through IMPEL, we actually helped them to get access to SBIR funding, and they also have expanded the manufacturing space into Massachusetts, where they are using an aerogel, which is transparent, which is a patented technology, so that they can increase the energy efficiency of their silica aerogel window inserts, which can also be used for retrofitting and not just for new buildings. Another example is Hydronic Shell Technologies, which is a very interesting startup which is actually a bidirectional startup which has been touched by both Epic as well as IMPEL. So David Goldstein went through both IMPEL and the Epic cluster, and they have been able to receive US DOE's Easy Home Electrification Prize, and they've also been able to test bed their very interesting hydronic shell technology at Syracuse. So our collaboration network at IMPEL consists of scientists, policy demonstration experts, investment specialists, and entrepreneurs. And this also includes Bing Dong, who I think just became a professor. Congratulations, Bing, who is also on our mentor panel. So our community is large. I would like to also mention that our applications open on July 15th of this year. So if anybody is interested as a startup or a researcher to help understand how to bring your building technologies to commercialization and get the heft of the national labs and the DOE behind you, please apply. Our applications open on July 15th. So that was about IMPEL. Based on the success of IMPEL, we've launched last year another new program, which is called Cradle to Commerce. So this essentially is about bringing intellectual property from the cradle of several national labs into commercialization. So we think of C2C as an unprecedented public-private partnership to provide the infrastructure commons to accelerate equitable climate tech entrepreneurship. And our website is c2c.lbl.gov. So if you think about the public and private sector partnership, DARPA, which is the Defense Advanced Research Programs Agency, when they invested in the World Wide Web and partnered with CERN out of Europe, they created the foundations of the internet, which is now synonymous with industry. Similarly, the US Department of Navy funded the first GPS, which is now in every watch and every phone across the globe. And NASA started space exploration, which is now synonymous with a lot of large private sector companies. So game-changing and society-changing technologies can only be made possible through the catalytic power of the government and the speed and scale that the private sector brings. So what we have done through Cradle to Commerce is provided this mission that we can provide the same speed and scale to climate. Climate is one of the most existential opportunities of our times. So what we want to do is ensure that the IP, which is produced by national labs, can be used at speed and scale to address the climate crisis, using government funding and the speed and scale of the private sector. So what we're trying to do is get the best talent and startups, the access to the topmost IP and key resources from national labs, which otherwise remain stuck inside our government infrastructure. So what we have done is created Cradle to Commerce, which is transforming cutting-edge IP into world-changing startups. So we've curated the best of our test beds and prototyping facilities, the best of our IP. We've built a consortium of 4 national labs and 3 incubators, and taken the support of 5 DOE offices, and we are providing 7 types of pro bono mentorship to create a climate tech infrastructure commons to accelerate climate tech. So we are looking at 4 domains, and each of these domains is led by one of our sister national labs. So we have nuclear as our first domain, which can address renewables intermittency. We have curated about 23 intellectual property cases, and this is being led by Idaho. We have 3 experts from Idaho, which are helping steer our nuclear startups by getting them integration to the IP available at Idaho and Oak Ridge, and also providing them access to test beds, which are otherwise not being able to access. Renewables is a second domain, which is being led by Berkeley Lab. Grid modernization and energy storage is the third domain, and buildings is the fourth domain led by Oak Ridge. And we've also partnered with 3 incubator partners, One Valley out of Silicon Valley, which brings powerful investor networks, The Engine at MIT out of Boston that brings tough tech expertise, and Decisive Point out of DC, which brings strong federal relationships. So the idea is to bring the best of science and the best of business together to help accelerate climate tech. This is our first cohort of teams, and they are basically, either using their own inventions. So for example, better batteries for buildings is a LBL-based startup where two of our scientists at LBL have partnered with an entrepreneur and they're bringing their own invention into commercialization. Whereas a different kind of startup is Electric Fish, which already had a product as a startup, and they have integrated Idaho and Argonne IP into the electric vehicle charging infrastructure, so they can integrate the IP and make their product much better and be able to accelerate their product to market. So what I'm saying is through Cradle to Commerce, we're not just bringing new startups into and getting them access to IP and test beds, but we're also creating new startups between inventors and at academic institutions with business folks coming from the inside. So these hybrid teams are being formed by Cradle to Commerce, and next week we are taking some of our teams to ARPA-E to give them exposure and to give them an insight into how to get to better government funding and how to get better access to national labs. So in a nutshell, I would say the innovation journey is tough. C2C accelerates the volume and velocity of clean energy startups. If you're at the early stage and you're going through the technological valley of death, at C2C, we provide vetted IP, test beds, scientists in residence, and grant funding. If you already kind of gone over the bench testing process and you are looking at getting to product prototyping and pilot production, we at C2C are able to support you through government pilots, through provision of prototyping facilities, as well as business support. And then, of course, this support will help you even when you get to the profitability valley of death by providing you access to the IP moat, which provides competitive advantage to your company, as well as access to public procurement and international markets through our DOE ecosystem. So in a nutshell, at C2C, we help to provide wraparound support for lab-to-market innovation by providing the IP, scientist and resident support, again, carbon tools training, mentorship support, and fundraising and ecosystem support. And this is really important in this time because the federal government is making huge, huge investments in regional innovation ecosystems. And this is really going to be the backbone of the climate tech economy in the future. Thank you very much for your attention. For more information, please reach out or go to one of our two websites, impel.lbl.gov and c2c.lbl.gov. Thank you.